Good morning, everyone. Today we are going to be talking about two important things. The main ideas for today's notes are one, standard form and switching between standard form and slope-intercept form, and two, systems of equations and solving them. And make sure that you get both the in these notes part and standard form written down. So what standard form is just another way of writing a linear equation instead of slope-intercept form. So now I'm about to write something in orange. Don't write the part that I'm about to write in orange. This is just to remind you. Slope-intercept form is when we say y equals mx plus b. Now do write what I'm going to be writing in black. Standard form, instead of saying y equals mx plus b, we say ax plus by equals c. And I'm going to show you a big example of this when we get done, but for now, just focus on what you've just seen and what I'm about to write here. So now, let's say that we need to switch to slope-intercept. Sorry, there was a cat getting into something it shouldn't have. So I've got ax plus by equals c. I can use a bit of algebra to figure out how I can convert this right here into slope-intercept form. So remember, in slope-intercept form, I want one of my two variables by itself, right? I want y by itself for it to be in slope-intercept form. So the first thing I do is I subtract ax from both sides. So then I have by equals negative ax plus c. Then I need to divide both sides by b. So then I'll have y equals negative a over b times x plus c over b. Draw. There we go. So now really, this is secretly in slope-intercept form already. It's just a matter of recognizing that the slope, or m, is the same as negative a over b, and the y-intercept, or usually we'd call it c, but here it's c stands for something else, so I'm just going to go directly to c over b. Alright, so let's see an example of this. You don't have to write this exact example down, I just want you to see it so you can see how it works. So now, let's say I have this equation right in front of me. I have 4x plus 2y equals 6. This should be showing up now. 4x plus 2y equals 6. Well, if I need to, I can convert this into slope-intercept form pretty easily. I can just say I'll start by subtracting 4x from both sides. Sorry, my computer is being really laggy when I use my iPad right now. So now I've got 2y equals negative 4x plus 6. Now if I divide both sides by 2, I'll get those 2's cancel. Y equals negative 2x plus 3. Now the truth of it is, these two equations right here, this y equals negative 2x plus 3, and the one that I started out with, where 4x plus 2y equals 6, those are the same. And to prove it, let's put it into a graphing calculator. So let's start out with our original equation. 4x plus 2y equals 6. So you can see the way that the line looks. It looks like it has a slope of negative 2, meaning it goes over 1 and down 2 between any 2 points. And now for the slope-intercept form version of this one that we just figured out over here, it is y equals negative 2x plus 3. So let's graph that on the same one. Y equals negative 2x plus 3. Now it looks like the red one disappeared. There's a good reason for that. It's because they're overlapping. They are the same line. It's just written differently. This one's standard form. This one's slope-intercept form. Usually slope-intercept form is a little bit more useful, but we're going to see one example today where standard form could be more useful. Our notes. Let's title this section Solving a System of Equations. And let's make that font way bigger. First, we're going to need a little bit of vocab. For starters, let's see, when you solve a system of equations, what is a system of equations exactly? So our vocab term is going to be system of equations. And we're going to have two definitions. One, the textbook way of thinking of a system of equations is a set of equations that have the same variables. Now, that is a terrific conceptual way to think of it. A way to think about it in a way that helps you actually get the work done and get the right answer like you want to and stuff is one graph, two lines. And now solving a system of equations. Solving a system of equations is finding the point of intersection for both equations. Another way to think about that is finding where lines cross. Then we're going to want to put x comma y. Now here's another one. Do write down these definitions. Don't write down the graph you're about to see. So let's say I've got these two equations right here. I've got x plus y equals 5 and 3x plus 2y equals 11. Well, the truth is, this is a system of equations because I've got two equations, x plus y equals 5 and 3x plus 2y equals 11. And they do have the same variables, x's and y's. Like if I changed this y to an a or something, they wouldn't be a system of equations anymore. But because I've got two variables and two equations and they share variables, I've got a system of equations. Now if I look over at the graph, This is where the idea of it being one graph, two lines comes in. And the way that I can, quote, solve this system of equations is by seeing where they cross. In this case, 1, 4. The solution to this system of equations is 1, 4, meaning x value 1, y value 4. That point is the, quote, solution. Now, because we just did this pure math style, there isn't a whole lot of context to this one. Now I'm going to give you an example with context. Do write this next example down. So let's say there is an entertainment sale at Media Barn. I'm pretty sure there's no major store with that name, which means legally I can use it. And at this entertainment sale at Media Barn, they're selling DVDs for $3 each and CDs for $2 each. Now I'm going to need to write these out in the form of X is DVDs and Y is CDs. And another thing I need to keep in mind when I write this out is I can spend, let's say I can spend up to $11. Or actually no, I want to spend exactly $11. And because I've only got a limited amount of space at my house, I only have room for 5 discs, both CDs and DVDs together. Well, I can write this out as in terms of how many CDs and DVDs I can get. This is going to form a system of equations. I can say X as in DVDs, plus Y, that's the CDs, equals 5. I can get 5 of them in total. Now another way I can write this is in terms of how much money I can spend and how much they cost. Alright, so X is DVD, so that's 3x plus 2y equals 11. Because it's $3 for each DVD and $2 for each CD. I have a graphing calculator. Like if I go to desmos.com/calculator, I can potentially be done here because I can type in x plus y equals 5 and 3x plus 2y equals 11, and then I'll see, oh, they come together at 1, 4. That means that is, since y is CDs and x is DVDs, the solution to this system of equations is 1, 4 in pure math terms. In not pure math terms, that means 1 DVD and 4 CDs. That satisfies that I'm going to get the 5 discs just like I wanted to, and I'm going to spend $11. Now there's one last way, and that is by putting it into slope-intercept form, just like we saw above, and putting them equal to each other. So slope-intercept form is y equals negative x plus 5. The next one is y equals negative 2 over 3x plus 11 over 2. Solve this just like a regular solving for one variable problem. Figure out what x was and use that to find y, but don't worry about it. We're not going to worry about that until next class. Have a good day.